I was already done, we were trying to find the subsequent inductor voltage and current in order to find the change as well. We were given our amps, which is our resistance, 5 ohms. We were given L. We were given our constant equation to find that for voltage. We were given our initial. So at 0 time, our initial current was 1 amp. In order to do that, we have to use Kirchhoff's second equation law, which is L times the change in current plus resistance times the current equals E of t. So we placed in all of our givens, and we were able to get this. And then we have to solve for our total current. But our total current, and it can only be broken down into our homogeneous or our current, our regular current, and then the particular, which we call our particular, which is the state, the regular state flow of current. Steady state, this is given by this. H of t is our transient current, and then IP is our steady state current. Two different ones. We solved for our homogeneous, which was the easier part. We literally had to just set that like that, integrate both sides, and you'll get that LNT equals CE, which C is just a constant because we have the derivative or an antiderivative, we have to add plus C. And then we have IP of t, which is a little bit harder. We notice that since the E of t has a cosine, we can just infer that this will be a cosine sine type of equation. So we have two coefficients that we have to solve for, A and B. In order to do that, we had to literally just derive our function, or equation, I should say. And we got 120, negative 120a sine 120t plus 120b cosine 120t. Once we did that, we go ahead and just plug that back into our differential equation. And we got this right here. This side is equal to the right side. But then we notice we have A and B. We have to solve for A and B. How would you do that? We basically grouped up like terms. We noticed that one side had cosine 120t. Also, the other side had cosine 120t right here. And we have a sine 120t and another sine 120t. But this time we added a sine over here just for sake of, since we have a coefficient that goes with this sine over here, we have to have a sine over there. So just to help solve. And we noticed that the coefficient, this 120b plus this 100a, should be equal to this 100 cosine right here. See this part right here? So this part is equal to this part. And then we have the sine right here. So somehow this 120, negative 120a plus 100b should be equal to the 0. And so we basically solve for A and B. But in this case, I solved for B first because I noticed over here, you can do A or B, but I chose B. This one is 0. So actually, if we solve for in this equation, say this equation, it will be a little more junked. I tried to do that first, but I switched up and changed it over here because I noticed that it's just 0. If you solve for B, like I did, you get 1.2a by first subtracting, or in this case, adding a on both sides, and divide by 100 to get b. So once you find our b is in terms of a, you go ahead and just plug that back in. And I had got 144a plus 100a equals 100. And then you solve for b by literally just adding the two like terms, the a's, and then dividing by the 244 on both sides. Yeah, you should roughly get about 630 over 61. Yep. Now that we have that, we have our A and B, we have our steady rate current equation. And now that we have that, we can go ahead and add that together with our homogeneous, or I should say, our regular current. And then we get total current is equal to CE, which is our C is a constant, again, just nothing, plus the IP, or steady rate current. We get that. But then we also were given the actual knowledge that at time 0, which is initial current, we have 1 amp. So then we can plug in 0 for t and set that equal to 1, and we can solve for our constant C. Our constant C will be our inductive voltage, or our constant to help find the inductive voltage, I should say. You plug that in, you go ahead and have this is equal to this because this cancels out. This becomes 0, so that's 0 right there. This just becomes 0, and anything times the power of 0 is 1, so c times 1 plus this, because again, cosine of 1, or cosine of 0, I should say, is 120 times 0 equals 0, of course. Cosine of 0, we already know our trig is 1, so you get 1 times that. Again, sine of 0 is 0. So we get that. We turn to the back. All right, let me see here. We have our total voltage with the inductance. We have this is equal to that. This is the answer that we got for going ahead and solving for the C. And then now we solve for the voltage. Okay. For the voltage, we have L times the change in current, which we already know our L is 0.05, and our change in current we found by deriving this top equation right here. And to do that, we got this, which basically is simple differential. And then we literally just brought out the coefficients because it's not much. It's chain rule basically. And we got this, and then we have to multiply everything, our new derived function, by our L. We got this. And you basically just, from here, you simplify, and you get this equation for voltage, which you can find the voltage by just plugging in 0, and then you'll basically get your voltage. That's it.